Okay, so this is going to be the first kinematics problem we're going to go through. The question is asking, David is driving at a steady 25 meters per second when he passes Tina, who is sitting at her car at rest. Tina begins to accelerate at a steady 2.8 meters per second at the instant when David passes. So drawing this out, basically what this says is we have a person whose name is David, and he is traveling 25 meters per second. That's his velocity. We also have a car. This car is at rest at the moment, but it will be traveling at 2.8 meters per second squared. So she begins to accelerate once David passes, one instant. So right here is when she's going to begin to accelerate. This means that her initial velocity right when they start is 0. That's her initial velocity. David's initial velocity, he's already going, so his initial velocity is actually 25. Using this idea, we're going to use an equation. We're going to say that x of t, this is going to be the distance one travels, is going to be equal to the initial distance plus the initial velocity times time plus 1/2 the acceleration, and this is going to be in the x direction, t squared. We're going to be using this equation for both David and Tina. So we know David's initial velocity is 25 meters per second. So we can put that in for the v naught. What's the x naught? Well, I can say whatever I want. In this case, I'm going to say x naught is equal to 0 meters for both of them. So they're going to start at a starting line. So for David, this is going to be David. We have x of t is equal to 0 plus the initial velocity, which is 25, times t. The acceleration is 0 because it says he's driving at a steady 25 meters per second. So he's not accelerating. So this is the equation 25t. What about for Tina? Well, that's going to be x of t is equal to 0 plus, well, the initial velocity is 0, so we don't have to worry about that term. But the acceleration is 2.8 meters per second squared, so it's going to be 1/2. This is going to be 2.8 t squared. The question is asking, the first question, how far does Tina drive before passing David? So they're going to meet again. So David's going to shoot off, and then Tina's going to come behind, but eventually she's going to pass. So we need to figure out when they're equal. So I'm going to set 25t equal to 1/2 2.8 t squared. From here, I'm going to divide by t, multiply by 2 to both sides, so I get 50 is equal to 2.8 t, and I get that t is equal to 50 divided by 2.8. This is the time it takes for them to meet again. I need to plug this back into either one of the equations to get the distance. I'm just going to plug it back into David's equation. So I get 25 times 50 divided by 2.8. And this is going to be the distance in meters that they meet again. The next question is saying, what is her speed? So when they meet again, how fast is she going? Speed referring to velocity. I want to know how many meters per second she's going. Well, she's accelerating, so she's going to keep accelerating. So we can figure this out. I'm going to use another equation, that v of t is equal to the initial velocity plus your acceleration times time. This is going to give me my total velocity at a certain time. And we already know what that time is as 50 over 2.8. So I can plug this in. I can say my velocity at 50 over 2.8, this is for Tina, is equal to the initial velocity, which we know is 0, plus the acceleration, which is 2.8, times the time, 50 divided by 2.8. So your velocity is going to be 2.8 times 50 divided by 2.8, which is equal to 50 meters per second. That's how fast she is going once she passes David. And those are the two solutions to this question. If you have any questions, please feel free to comment on the video and I will answer back. Thank you.